In order to make things cushy, I do divide my electrical load table into 9 columns. The first column here is my SN, which is the serial number, but in electrical term it means the circuit number. The second is the circuit code, while the third is the MCB rating, cable size, load per point, diversity factor, number of points, load per phase, and the circuit description. The first column, which means the circuit number, contains set of ascending numbers. So in this our example we have 1 to 10, while in this our project it is 1 to 12. The circuit number is in multiple of 3, which implies we can have 3, 6, 9, 12, 15, 18, 24. So, and it means the numbers of circuits the distribution board can hold. And on a norm, every distribution board do have red, yellow, and blue faces. So for this our project here, we are having 18. Moreover, the circuit number is what do determine the conventional name for distribution board. For example, in the market, if they said D4 board, it implies it have 12 circuits. D4, D1 board, 3, D2, 6. And on our second column here, we have the circuit code. For example, in this our project, the entire ground floor circuit are being noted in code A. So that's why we have A4, A10, etc. And I denoted the first floor in circuit B, B3, B8, etc. So every electrical circuit are always being denoted in code. So here is the representations. And in our third column, we have the MCB rating, which is the miniature circuit breaker rating. So this is the size of the breakers that we will have in our distribution board. So it's a measure of standard 2. For lighting points, the standard is 10. For socket, the maximum is 30. So 30 ampere, especially all these ring and radial circuits, the maximum is 30. For cooker control unit, although it depends on the size of the cooker, but the maximum is 45. Because on a norm, the maximum for cooker is 9 kilowatt, and if we use the conventional P equals to IV, our I will equals to 37.5. So using the nearest available circuit breaker, that's why we use 45 in this project. For AC is 20, although people do use 15 amperes too. So 20. And the next section is the cable sizes. And as we all know, cable size is a factor of the load, likewise the voltage drop, and sometimes the temperature of such an environment. But the way we used to do it for our table here is that we do select the standard maximum cable from the MCB rating. So for an MCB rating of 10 ampere, the cable sizes, the maximum is 1.5, and for cable sizes of sockets on a norm is 2.5. While for hot water heater we do use 4, and cooker control unit is 6. For normal AC is 4, and if we have other loads too, it will definitely be included. Proceeding to the load per point column. Load per point is a standard, is an electrical standard we do use in the industry. It's an assumption of the maximum load fittings or electrical equipment can have. For example, lighting, the standard is 100, while for socket is 300. and for cooker control unit is 2000, and likewise for AC. So for other appliances too, such as the elevator is around 1.5 if I'm right, etc. So you can actually calculate it through the P equals to IV formula too. And for the diversity factor, which is a ratio of the installed load and the running load, many professionals always do mistake on the diversity factor. I will be writing a comprehensive explanation on it, but on a norm we have 4 types of diversity factor. So we have the diversity factor for circuits, which is under IEC standard. Likewise, we have diversity factors for switchboard, and we have diversity factor for distribution network, and we also have the diversity factor for buildings. So I will be elucidating this in further video. So since we are designing for circuit here, because we have circuit number here, so we'll be using diversity factor for circuit. If we are designing for switchboard, which implies in the main panel, we'll be using the diversity factor for panel. And if we are designing for network, especially if it works in a generating system, we'll be using the diversity factor. And proceeding to the number of circuit per point, which is the number of appliances or fixtures we have in such a circuit. So in this our lighting points we have 19. So let's practicalize in the project. So we have 19. So what's the number of lighting fixtures we have here? This is our circuit A1. So we count the number of fixtures here: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. So these are how we do counting. So it is the number of points or number of connected units in such a circuit. You know, AC do takes its own line. That's why we have 1111 here. So but for our socket, that's why we have 759. The maximum for socket is 10, while the assumed maximum for lighting point is 24, but we always try to limit it to 10. And proceeding to the next column is our load per phase, which is a cumulative result of the number of circuits here, likewise the diversity factor and the load per point. So if you click on this, you see F11 times F12 times G11 rather, and times H11. So this is our main this is one of our main concern for designing the spreadsheet. And finally is our description, which I only include this to make it easier to locate the circuit in our project design. And as you know, we have 5 types of electrical loads. So we have the conveyance system loads, which is for the elevator extractor. We have the HVAC load, that's why we have our ACA. We have the lighting loads. We have the power loads and the low power. Low power is all the CCTV, intercom, etc. So this is all what the columns entails in this our load spreadsheet.